Alright, so here's a little update on the Biqu H2 extruder now installed on my railcore. So yeah, right now it's printing this marble PLA at 120 millimeter per second, 0.4 nozzle and 0.24 layer height. So it's a bit noisy, but it's handling it pretty well. If you can see, the surface aspect is pretty good. Here's a cool little thing as well. Here's my filament sensor. Each pulse here is equivalent to 2 millimeters of filament being fed through. So this little filament sensor here, it monitors both runout as well as clogs. And clogs there has been, so that's what I wanted to get over for this video. So yeah, the first thing that I had to do after the previous video when we are assembling it is fixing this assembly screws situation. So as a reminder, the extruder came with its 2 assembly screws, pretty loose. And I found out while we are assembling that if I clamp it down all the way, then the little tensioning arm here would not move, yeah, it would seize. And so what I found out after measuring it is that this little lever is actually thicker than the slot it's supposed to slide in. So whereas there should have been some clearance, it's actually in interference. So yeah, of course that was gonna cause some problems. So what I had to do here is, I don't know if you can see it, yeah, the little strip of shiny aluminum here, I had to basically file it down so that it can slide fully again. So yeah, once this was solved, yeah, creating the mount for the railcore, which isn't too easy actually, because the way it's assembled with these threaded screws inside the extruder, that makes it quite difficult to find any decent way of attaching it. And more so is the fact that the screws here are actually on a separate part than the nozzle. I think it would have made more sense to have the screws closer to where the nozzle is, as this is where you need most of the rigidity, because as a result of it, there is a bit of overhang, right, between where the screws are and the nozzle. You can see here, from these screws here, that they are the same all around. So yeah, that's not the ideal in terms of rigidity. Next thing, so I purchased the stainless steel all metal Hotend throat or heat brake. Yeah, this is the one that came with it. That's the one that is sold on the Biqu site. And I found out that these two are actually not the same size. I don't know if you can see, but the full metal, all metal Biqu heat break is actually 1.3 millimeter shorter, and so as a result of that, I had to redesign my part cooling fan. But overall, the biggest issue that I have, I'm just going to move it to stealthy right there. Yeah, I think it must be much better. And we'll get back to it in a moment with at least one last positive point about that. But yeah, I expected a much better performance from this design with flexibles. And what I found out is that it has a really high tendency to clog. So not in the nozzle, but in the extruder. So what happens is the filament gets pushed sideways, and it gets stuck in the gears. So I was expecting much better than that from this design, and I'll have to have a second look at it, disassemble it. I'm thinking that the alignment of the gears in relation to the throat may be off, or simply the clearance. Yeah, there might be simply too much clearance. Here are two prints that were aborted before I could reach any significant progress. This is TPU. I think this light is actually really hard on the print. It looks much better on a softer light. Actually, this is not bad, right? It allows to see a bit more of the defect. But yeah, for the time that it worked, the extrusion was very consistent. I haven't quite tuned the retraction so well, but yeah, after cleaning, it did look pretty fine. This was printed at 65 millimeter per second, which was not an issue on my Mark 8. So that's the biggest turn down. I was really expecting a better out of the box performance with flexible. Another issue that I found is that there is very little documentation on the Thermistor. So with the default NTC 3.9K settings, I measured a discrepancy of 15 degrees between the Thermistor temperature and the real temperature measured with probe down the throat. So yeah, I'm just accounting for it by changing my profile, adding 15 degrees to it. So apart from that, it's if it weren't for the flexible, it's a pretty precise and lightweight extruder. It's also pretty silent. This fan here is really silent. I can hardly hear it. Much better than this Mosquito 25 millimeter, I recall. This was absolutely screaming. So yeah, right now it's running in stealth shop with a speed limit to 80 millimeter per second. And it's doing a bit of noise because it's right at the limit of what this build can achieve, as I'm running pretty beefy NEMA 23 motors with a lot of back EMF. So I'm pretty limited in terms of maximum speed in Stealth Job. So yeah, my outlook now after having tested it a bit further is yeah, a bit underwhelmed, to be honest. I'll have to reopen it up and figure out exactly where could yeah, this clog issue come from, and hopefully that's something I can fix. Otherwise I have to look for different options. So yeah, hope you get some more clarification on it, and yeah, cheers.